Hello, and welcome back to another IB Math Speedrun with me, Vince. And so today we're going to be going, in this speedrun, we're going to be going over cumulative frequencies. So let's jump right in. So when we have raw data, then it's quite easy to find the median of the raw data. We can either arrange them all in order, or we can, and the quartiles is the same thing. However, when we have group data, when we have, data that's in intervals, it can be quite hard to find the median sometimes. And so what we can do is we can plot the data on a cumulative frequency curve. So what this does is on the x-axis, we have the set of data values, like whatever values. And on the y-axis, we have the cumulative frequency, which is like if we add up from this value and all the data values before it, what's the new value? So say like most cumulative frequency curves, well, they first all start at 0, 0, since at the 0th data point, or like the lowest data point, there should be 0 items, and then they go upwards. So each cumulative frequency is plotted against the upper boundary of the class. So if your class is between 10 and 20, we'll plot it at the upper class, and then the cumulative frequency associated with the highest class value, or the one to the most of the right of the curve, must be the same as the total frequency. So we plot some points like this. Notice the points to the right can never have a lower y value than the points to the left. And then we join them up with a curve. So from here, we can take the median frequency, draw a line to the curve, and find out what value would be the median, and the same for the first quartile and the third quartile. So that's how you would use a cumulative frequency curve. So yeah, that's all really. I think we need to do some questions to jump into. So I'm gonna do the even ones, maybe they're a bit harder. So we need to, first question is we need to consider the data set k minus 3, k plus 2, k plus 5, where k is a real number. Find the mean of this data set, and then each number in the set is decreased by 3. Find the mean of this new data set. This isn't even a cumulative frequency question. I don't know why this is here. Find the mean of this data set. Add up all 3, divide by 3. So we have 3k plus 2 plus 5 is 7 minus 3 is 4. So we have k plus 4/3 as the mean. Each number in the set is decreased by 3. If each number is decreased by 3, that means the mean also decreases by 3. So the new mean would be equal to k plus 4/3 minus 3, which is equal to k minus 5/3. Hold on. Oh, I missed the number. That's why I was like, what's going on? Okay, anyway, sorry, there should be a k in between here. So we actually have 4k plus 4, and with 4 terms, we actually have simply k plus 1. And so the new mean would be k plus 1 minus 3, which is k minus 2. So yeah, I don't know why that was here. Let's move on to an actual cumulative frequency question. So what we have is, I'm going to show the graph here because it's pretty hard to draw out. So there we go. So we have, where are we? Here. The height in meters of a random sample of 80 cows in the field were measured against this following graph. So first, we need to estimate the median of this data. We can estimate the median of this data. It's actually nice, I can draw on this browser. But the median of this data would be, well, the maximum cumulative frequency is 80, the minimum is 0, so the median would be at 40. So we draw the line here. And then wherever this intersects, we draw this line down. Hopefully a bit straighter than I did. So let's draw that line down again. And I would estimate it to be 1.175. That looks like around the middle. So next, we need to estimate the interquartile range for the data. And the interquartile range, well, let's get at 28, what is this equal to? It's around 1.125. And around 60, what is it equal to? It's around 1.2125. So from 1.2125 minus 1.125. I mean 1.225. This is the median is equal to 1.175, and 1.225 minus 1.125 is 0.1. So I would estimate the interquartile range is 0.1. What else? And so draw a frequency table for the height of the cows using a class width of 0.05 meters. Okay, so let's draw that table. So if we have a class width of 0.05 meters, we have 1 to 1.5. We have 1.5. Actually, I'm just going to list it down. It's a bit hard using drawing it. So 1 to 1.05. Well, what's this point on the curve? I'd say that's around 5. 1.5 to 1.10. Well, what's this point on the curve? I'd say that's around 15, so I'd give this class 10. So what's 1.10 to 1.15? I'd say that's maybe just around there, 25-ish. (1.15 to 1.20). 1.20 is at 50, so we're going from 25 to 50, so it's around 25, a good 25 units. 1.20 to 1.25, so 70 to 50 is around 20. It's around 20 units, and finally, if we add all of these up, we should get 1.25 to 1.30. That's around 10 for me, and it should also be around 10 here. So 1.25 to 1.30. Around 10. Yeah, and like these, obviously it's pretty hard to tell from the graph, especially if you don't have the graph on paper, what the exact values are. So as long as they're around the exact values, it should be okay. Okay, next, a cow is selected at random. Find the probability that its height is less than or equal to 1.15. Given that its height is less than or equal to 1.15, find the probability is less than or equal to 1.12. Okay. Let's erase all of these marks. So we need to get the number of elements that are less than or equal to 1.15. So we can draw this line up here, and if we estimate that that's around, actually 25 is a pretty bad estimate. I will use 27. I'll say 27 cows out of the 80 are less than 1.15 meters or less. So that means that we have 27 over 80, so it's around a 33.75% chance that the cow will be less than 1.15 meters. If it is less than 1.15 meters, we need to find the probability that's less than 1.12, which I'm going to mark down here. And I'm going to say that's around 17 meters. So this probability is 17 over 27, which is equal to roughly 63%. These values your values that you get for these two will differ because, you know, you might read a different amount here, but as long as they're around the same correct value, it should be okay. So yeah, that's all for this speedrun. I hope you enjoyed the speedrun, and I hope to see you in the next one. See you then.